I thought you guys might use some help on getting some word problems set up, particularly if they are area and volume word problems. So here's the first problem. We want to enclose a rectangular region bordering a river with fencing on 3 sides and down the middle. The way that that looks. Here's the river. And then we've got fencing on 3 sides and a piece down the middle. X represents the length of each of the parallel pieces. So there's X, X, X. We have 600 feet of fencing available. So the first question, what is the length of the remaining piece of fencing in terms of X? Well, here's what needs to happen. I would start by calling that whole length Y, at least temporarily, because I know if I add X plus X plus X plus Y, it needs to equal 600. So that tells me 3x plus y is 600. So that last piece is really 600 minus 3x. So that's this one. Determine a function a that represents the total area of the enclosed region and give any restrictions on x. So we know that area is length times width. So in this case, it would be x times y. Or we could say it's x times 600 minus 3x. The restrictions on x are so that you know how to set up your window. So what are things that x can't be? Well, we know that x has to be positive. And we also know that since we have 3 pieces here, the 3 of them together added up to 600, meaning that each one of those has to be less than 200 feet. Right, so we're looking for something that's, there's your restrictions on x. That's probably going to be your x min and x max in your window. The next question asks, what dimensions for the total enclosed region would give us an area of 22,500 feet? So what we need to do is we need to graph this. So I'm going to go into my y equals, and I'm going to put x times 600 minus 3x. And when I set up my window, I know that x's have to be in between 0 and 300. And I'm looking for a y value of 22,000. So I might make this like 30,000. I've made my minimum 1,000 just so that I can see slightly below. And we'll see if that works. It sure does. So now I need to look at this 22,500. So I'm going to second trace, intersect. I want this line and this line. And I want this intersection point. And I have x equals 50. If I do it again, I have x equals 150. So I know that x can equal 50, or x can equal 150. And I know that y, remember we figured that out, was 600 minus 3x. So y can equal 450. Or y can equal 150. So the dimensions are 50, 450, 150, 150. Finally, we're asked for the maximum area that can be enclosed. So you go back to second trace. You want the maximum. You need to move your cursor to the left of that maximum. You need to move your cursor then to the right of the maximum, and then hit enter. And the maximum that can be enclosed is 30,000 square feet if your x value is 100. So we could figure out y. Next problem is a volume problem, and it tells us that a piece of sheet metal is 2.5 times long as it is wide. We'll make it into a box with an open top by cutting 3-inch squares from each corner and folding up the sides. So we're cutting out these little corners here, and each one of them is 3 by 3. It says that x is our original width, which means that our original length is 2.5x. So represent the length of the original piece of sheet metal in terms of x. Well, it's just 2.5 times x. What are the restrictions on x? Well, we know that x has to be bigger than 6. Determine a function v that represents the volume of the box in terms of x. So for that volume is length times width times height. This particular box, when you fold it up, looks like this. Here's your 3 inches. Here's your x minus 6, and this is your 2.5x minus 6. So what I did was I said this distance is here. So I had to take all of x and remove 3 from each side. Same thing here. 2.5x minus 3 minus 3. So now if I need volume, my length is 3 times x minus 6 times 2.5x minus 6. So for what values of x will the volume of the box be between 600 and 800 square inches? For that, we will look at a graph. For this, we'll need to put an equation into the y equals. When we looked at our restrictions, all we said was that x had to be greater than 6. I've made the maximum 20. For the y's, we're looking for values between 600 and 800, so I've made my y maximum 1,000. and then the minimum is negative 100, the scale is 100, just to give myself some space. So here's what that graph looks like. If I'm looking between 600 and 800, what I'm looking for, this will give me a volume of 600, that will give me a volume of 800. So I'm looking for the intersection here, and my guess over here. So that's about 13.3. I can do it again. Here, I want y sub 3, and it's 14.7. So, for this one, I've got, what did we say, about 13.3 and 14.7. So for x values that are between 13.3 inches and 14.7 inches, I will have volume that's somewhere between 600 square inches and 800 square inches.